Okay, for what we have in this problem, it says to suppose that the functions f and g are defined for all real numbers x as follows. So we have that f of x is equal to 3x minus 3, and that g of x is equal to 6x. And we have, first of all, okay, we're looking for f times g of x. Okay, so we have for the product function f times g of x. Okay, this will be in reference to f of x times g of x. And again, we have with f of x, okay, we have 3x minus 3. And we have times g of x, which we have at 6x. And you can look at this where we have 6x and 3x minus 3 multiplying each other, which they are. And 3x times 6x, this will make 18x squared. And minus 3 times 6x, so this will be a minus 18x. And then we have for the next portion, okay, we have for f minus g of x. So we have f of x minus g of x. Again, we have with f of x, we have 3x minus 3. We have minus g of x, so we have minus 6x. So it comes down to 3x minus 3 minus 6x. 3x minus 6x becomes negative 3x. And we have followed by the subtraction of 3. And now, for what we have in the case of f plus g of 4. Okay, and we can just say we have going ahead and determining the values of f of 4 and g of 4. Now, f of 4, okay, this will be 3 times 4. Minus 3. 3 times 4 is 12. Minus 3, which is 9. For g of 4, okay, we have 6 times 4, which will be at 24. And so we're going to have for f plus g of 4, so taking the specific case in advance, okay, so we have f of 4 plus g of 4. And so we have 9 plus 24, and that will be at 33. So plugging in what we have here, so f times g of x, so we have 18x squared minus 18x. For f minus g of x, again we have negative 3x minus 3. And for f plus g of 4, again, we have to come out to 33 and checking, and the result is correct. Okay, now we have, suppose that the functions f and g are defined as follows, whereupon we have f of x is equal to 3x squared minus 5, and we have g of x is equal to 9x minus 8. And we have in part A, it says to find f over g of 3. And we're going to involve both f of 3 and g of 3. And we can use either the specific or the general case in advance. Okay, so we have with f of 3, okay, so we have 3 times, okay, the square of 3 minus 5, and we have 3 squared is 9, we have 3 times 9, which will be 27, minus 5, and so this will come out to 22. As for g of 3, we have 9 times 3, which is 27, minus 8, and 27 minus 8 comes out to 19. Okay, so for f over g of 3, so we're going to have f of 3 over g of 3. And so that is going to end up at 22/19. And in the case of the domain of f over g of 3, okay, now, okay, so we have with f over g of x, okay, we have f of x over g of x. And so we have 3x squared minus 5 all over 9x minus 8. And for what we have excluded from the domain. Okay, so we have that 9x minus 8 cannot be 0. And taking what we have here, we have that 9x cannot be equal to 8. And we have with division by 9. Okay, we have the x cannot be 8/9. Okay, so we have for f over g of 3. Okay, so you have 22/19. And values not in the domain of f over g. Okay, so that is going to be at 8/9. And so we have checking, and the result is correct. Okay, now we have the functions u of x and w of x respectively at x squared plus 6 and the square root of x plus 1. And it says to find the following. Okay, so we have u composed of w whenever x is equal to 3. Okay, so we have in this particular setting, okay, so we have for u composed of w of 3. Okay, so we're looking at taking u of w of 3, and we can go ahead and determine just what w of 3 is going to be. Okay, so you have w of 3 is equal to the square root of 3 plus 1. 3 plus 1 is 4, and the square root of 4 is equal to 2. So we're looking at what's going to be u of 2. And for what we have been following through, okay, so you have with operating in accordance with u of x, okay, with x at 2. So we're going to end up with 2 squared plus 6, and 2 squared is 4, and 4 plus 6 is equal to 10. And if we reverse the order, so we have w composed with u of 3 so we have w of u of 3, and for what we have in the case of u of 3, okay, so u of 3, okay, we're going to have at 3 squared plus 6. 3 squared is 9 plus 6, which will come out to 15. So we have in following through, okay, so we have w of 15, and following through in accordance with w of x. So we're going to have the square root of what is going to be 15 plus 1. And so we have the square root of 16, and the square root of 16 in turn is equal to 4. So the first composition, the outcome we have at 10, and the next, okay, we have at 4, and checking, and the result is correct. Okay, so we have with the following composition problem. Okay, now we have, okay, for the first set, okay, have the domain of G and the range of G. And, okay, now we have, first of all, okay, we have G. I'll use a little bit of highlighting here. So you have G of 1 is equal to 5. And we have next in line, okay, so we have G of 2. And that's equal to 6. And we have G of 6. And that is equal to 2. And we have G of 8. And G of 8, okay, we have equal to 5. Okay. And for what we have for F, okay, let me mention, in case you have the domain of F composed with G. Now, some of these values I have in red, 1, 2, 6, and 8, will be in the domain. Now, in terms of what we have regarding F, okay, so right now we have F of 0 is equal to 6. And we have F of 4 is equal to 8. And we have F of 5, okay, is equal to 7. And we have f of 6 is equal to 7. And we have f of 8 is equal to 6. And we have for the correspondence in the mapping, we have f of 9 is equal to 0. So we have for f composed with g of x, okay, so we're looking at f of g of x. And so for what we have here, so we have f of g of 1 okay, and g of 1 is equal to 5. Guess what? We have f of 5 is going to be equal to 7. And we have next up, okay, so you have f of g of 2. And guess what? G of 2 is equal to 6. And for f of 6, okay, this is also going to be at 7. And we have next in line, okay, so you have f of g of 6 and g of 6 is equal to 2. And we have for f of 2, well, guess what? There's no f of 2 in the mix. Okay, so this one does not exist. And we have with f of g of 8. G of 8 is equal to 5. And we have f of 5. And so this will come out to 7. Okay, so we have, considering that this part does not exist, okay, now we're going to have, in the case of the domain is going to consist of the values 1, 2, and 8. And for what we have in the case of the range will consist of just the number 7. So we have for, again, the domain, okay, so you have 1, 2, and 8. For the range, okay, we have just the number 7. And checking the result, and that is correct. Okay, and we have here for the real valued functions, f of x equals 2x plus 1, and g of x equals the square root of x minus 5. It says to find the composition where we have f composed of g of x and specify its domain using interval notation. Okay, so we have, in the case of f composed with g of x, okay, so we're looking at f of g of x. Okay, and for g of x, okay, so we have f of the square root of x minus 5. And in terms of the follow through, okay, so we have in accordance with f of x is equal to 2x plus 1. We're going to have f the input equal to 2 times the input plus 1. Now with the input situated as the square root of x minus 5, we have 2 times the square root of x minus 1. Make that 2 times the square root of x minus 5. Okay, followed by the addition of 1. And there's really nothing new to add here. So we have further restrictions. Now the input, okay, now we have the square root of x minus 5. And so we have for the input, x minus 5 cannot be negative. And so we're going to have the x minus 5. It can be 0 and it can be positive. So we have the x is greater than or equal to 5. And we're going to have the same bit of history here. Okay, we have the output at 2 times the square root of x minus 5 plus 1. And so you have altogether, okay, x minus 5 greater than or equal to 0. And we have the x is greater than or equal to 5. So the input and the output restriction will be identical. So the combined restriction it's going to be x is greater than or equal to 5. And so we're going to have for the domain, so you have from and including 5 going out to infinity. All right, so we have in this particular case applying what we have here. Okay, so you have what's going to be 2 times, okay, the square root of x minus 5 followed by the addition of 1. And for the domain, so you're going to have in the bracket, so you have the number 5, and we have the upper limit, so you have going out to infinity and checking, and the result is correct. Okay, now we have in this item, it says to find the difference quotient f of x plus h minus f of x over h, whereupon x does not equal to 0 for the function below. And it says to simplify your answer as much as possible. Okay, so we have f of x is equal to 2x squared plus 5. So that is the f of x part. Now for f of x plus h, for x plus h, now we're going to have 2 times the square of x plus h, and I will mention, okay, so we have with x plus h squared, we have x plus h times x plus h. So we have x squared, you can see we have plus hx, so this will be 2hx. We have plus h squared. And so we have in the follow through, okay, so you have 2 times the square of x plus h, followed by the addition of 5. Okay, so we're going to have a 4-term expression. So we have 2x squared plus 4hx plus 2h squared plus 5. Okay, and taking what we have now with f of x plus h minus f of x all over h. So filling in what we have with the expressions, so you have 2x squared plus 4hx plus 2h squared plus 5. And you have minus f of x, so f of x we have 2x squared plus 5. We have all over h. And if you were to combine like terms, now what would happen here is that 2x squared would go out, since we would have 2x squared minus 2x squared. And you have 5 to go out, so you have a 5 minus 5. So this is going to come down to 4hx plus 2h squared over h. And we have, upon simplifying, okay, notice we have a common factor with h. So you have h times the quantity of 4x plus 2h all over h. And so we're going to have a set of h's to cancel. So we have in the final result, we have at 4x plus 2h. And so in going back and checking, and the result is correct. Okay, now we have given f of x is equal to 1 over x minus 6. It says to find the difference quotient f of x plus h minus f of x over h, where h does not equal to 0. So I have f of x is equal to 1 over x minus 6. And if I take what I have here and determine what f of x plus h will be, so we have 1 over, and extending x on out to x plus h. Okay, so for f of x plus h, that's going to be 1 over x plus h minus 6. And for what we have in the case of the difference quotient, okay, so I have f of x plus h minus f of x. You have over h So we have 1 over x plus h minus 6. We have minus 1 over x minus 6. And you have all over h. And just taking what we have for the difference. Okay, so we'll just take, again, the difference between the two ratios and then follow through with the division by h. And if I combine these together, now the least common denominator, we have x plus h minus 6, quantity times the quantity of x minus 6. So we have in the first ratio, we have 1 over x plus h minus 6, multiplied by 1 in the form of the missing factor, x minus 6, divided by itself. And we have minus, okay, we have 1 over x minus 6. And from the least common denominator, we have the x minus 6, but we are missing the x plus h minus 6. So looking at what we have now, okay, so we had the least common denominator. And then we have first set of terms. Okay, we have in the numerators, we have 1 times x minus 6. And we have minus, okay, what's going to be the quantity of x plus h minus 6. And we have x's will go out. And we're going to have negative 6, and what's going to be plus 6. So this will come down to negative h all over x plus h minus 6 times the quantity of x minus 6. And so just taking what we have here, so we have this difference combined, and we have a division by h. And dividing by h will be the same as multiplying by the reciprocal of h. Okay, and you could have gone ahead and canceled out the h. I just wanted to mention in case you have with this result, you still have the negative sign left over. So this will come down to minus 1 all over x plus h minus 6 times the quantity of x minus 6. Okay. So in looking at what we have upon checking, okay, so we have the negative of 1 over, and we have the quantity, okay, so we have x plus h minus 6 times x minus 6, and checking, and the result is correct.